A warm season's greetings to all. It is my privilege to welcome you all to this technical session of 4th International Virtual Conference on Viksit Bharat, a visionary platform that brings together scholars, innovators, practitioners committed to shaping a resilient, inclusive, and sustainable India. I, Ravi S Tank, Director for Center for Total Quality Management, Atamiya University Rajkot, has an honor to serve as a session chair for today's deliberations. I extend my sincere appreciation to Dr. Arjun Dave, Director, Vedant Knowledge System Private Limited, and his team for his leadership and for conceptualizing this conference that bridges research, policy, and practice in alignment with national vision of Viksit Bharat 2047. The 6 papers in this session, which is allotted to me, reflects the spirit of quality, innovation, sustainability, and social impact, the very pillars on which the Viksit Bharat is built. I encourage all presenters to share their insight confidently and all participants to engage actively. Let us use this platform to exchange ideas, inspire innovation, and contribute to India's journey towards Viksit Bharat 2047. Thank you, and I now invite the first presenter to begin the session. Thank you very much.
Hi everyone, my name is Ashu Kalra and I work for EXS Service. I'm a PhD scholar at MIT University, Noida. Today, I'm excited to present my study on 4th International Virtual Multidisciplinary Conference. And my subject of my paper is a comparative assessment and performance validation of UHGBC IGBC guideline for self-sustainable net zero buildings. As we move forward, there is a distribution of within 5 categories. We'll talk about the background, overview of UHGBC and IGBC guidelines, the barriers, the challenges. We'll validate it by doing 2 different buildings. We have taken the data and the recommendation how we can take it forward. The background is if you look at that 40% of the overall emission comes from the buildings. And if buildings become self-sustainable, that is how we can control the emission. If you look at the building sector is going to double by 2050, I think it will be good that we look at framework like UHGBC, IGBC, and bring them forward to make sure that all the buildings are energy efficient and environmental friendly. If we talk about UHGBC, lead is something which they give, which is lead silver, lead bronze, lead gold, lead platinum. And what did they do? They talk about, and lead is technically leadership in energy and environment design. UHGBC started in 1998. So when they look at lead, they look at multiple different parameters like energy, water, sustainability, the material, what we pick to create that particular building, indoor environmental quality, and innovation, how we have adopted innovation to make sure that our building is energy efficient, less uses of water, and environmental friendly. If you look at this framework, this is holistic. And while if you look at the limitation, I think operationally this is less focused. So we will be putting a lot of lights as we move forward. IGBC is actually Indian Green Building Council, which is an Indian arm of USGBC. Started in India in 2001 and did over 10,000 projects. If you look at the size, it is around 10 billion square feet in India. Again, very close to USGBC. Like I said, it's an arm of USGBC, climate sensitive, cost effective. But again, the way we talk about the operational, so I think here no embodied carbon assessment. And there's no mandate to adopt renewable energy. It only talks about energy efficiency, water, and maybe the material selection, what we do to build that particular building. Let's talk about building, which is a Suzlon building, and this is in Pune. This building is LEED Platinum. and this is a five-star Greha. It is 100% electrified via solar or wind, hybrid manner. Rainwater harvested is 100%, 100% wastewater recycling. If you look at their designing, yes, passive design. They use natural daylight to make sure everything is in alignment with the LEED Platinum standard. And their EPI is 55.86 kWh per square meter per year, which is actually 47% less than a conventional building. So idea was to bring the energy efficiency if we compare a LEED Platinum building to a conventional building, 47% less. It is directly proportional to scope 2 emissions, so that is also 47% less if assuming we are not using any renewable energy. I think there are five key gaps when we look at the guidelines of USGBC and then IGBC. I think the first one is operational performance. The second thing is there's no mandate to adopt renewable energy or use renewable energy for the operations. Embodied carbon is something which we can talk about. Digital, I think in this era of artificial intelligence, we should look at a lot of stuff where we can use AI and bring digital monitoring, and then alignment with the policy. I think these are the five different buckets of barriers which we thought we will put and we will take it forward. What we also did, we took the data for two different buildings in National Capital Region. And when we look at the data, the one building was a LEED building and another building was a non-LEED building in Noida and Delhi. So I think what we looked at energy performance, and we just look at the data. In the next slide, we are doing the results of the data where we see almost 40.1% reduction if we compare the energy efficiency. So that is something which is straightforward, giving us a carbon intensity reduction. So I think this is something we want to bring on this particular study. Global trends on policy alignment, while EU is looking at something, and we can talk about living building challenge. I think they're also pushed towards regenerative net positive buildings. And then IFC Edge, I think they're also looking at net zero performance frameworks as well as NZEB, which is net zero energy buildings. Recommendation, I think the first one is that a minimum percentage should be decided for the renewable energy. The second we can talk about is mandatory EPD for industrial sector. The third is circular economy integration. I think this is from making sure that there are recycled material which are being used, and there's a target on this particular thing. I think post-occupancy performance validation, this is something which should be done after 12 months so that we can access the operational data, which we really miss we show as a barrier. And I think the digital transformation in this era of artificial intelligence, they should definitely bring a lot of stuff where we can use AI, IoT, digital twins, and make sure our buildings are energy efficient, sustainable, and net zero building. At the end, I think idea was to strengthen the uh, lead certification or maybe the IGBC guideline into performance stream. It should be aligned with our net zero framework because there's a 40% emission coming from the building, and it is necessary we align, we make sure the barriers are taken care. There are policy changes, there are mandates where we can drive long-term climate resilience and national sustainability goals. Thank you very much. And I was thankful to the conference organizers to give me this opportunity to present my paper. Thank you very much once again.
Thank you very much, Ashu Kalra ji, Vice President, Head of Global Corporate, Real Estate and Environmental Sustainability, Excel. You have given your manuscript on a comparative assessment and performance validation of USGBC and IGBC guidelines for self-sustaining net zero building. I must give one point before I begin. Your presentation was stuck on the first slide itself. The slide you forgot to change. It was not on a presentation mode. But however, going through the manuscript which you have submitted, the paper presents a comprehensive, well structured, and timely analysis of lead, that is USGBC and IGBC framework, in context of achieving self sustaining net zero building. It effectively combines a policy level critic, global benchmarking, and quantitative performance validation, making it highly relevant for researchers, practitioners, and policymakers. The strength of your presentation, the manuscript, was that you have given a clear articulation of the gap between green certification and true net zero performance. You have also given a strong comparative framework supported by tables, case studies, and normalized energy carbon analysis. You have also included a real building performance data which adds empirical credibility to your research paper. Alignment of global climate commitments, SDG, and emerging international standards is also appreciated. But I would also suggest you some more points for improvement, like you can also briefly clarify data boundaries, assumptions, and uncertainty in quantitative comparison to enhance reproducibility. You can also implicitly outline AI and IoT or digital twin based research direction would further enhance the innovation appeal in your research paper. Overall, the paper makes a valuable contribution to the sustainability discourse, particularly in the Indian and developing country context. So, congratulate you. Thank you very much for your paper.
I am Kanupriya Sharma, Assistant Professor, Department of Chemistry in Bihani Girls College, Jaipur, Rajasthan, in the conference from Gurukul to Global Paving Path to Viksit Bharat at the rate 2047, Restructuring Higher Education with Indic Priorities, going to present a paper, Green Chemistry, an Eco-Friendly Approach for Sustainable Development. It is a transformative, green chemistry is a transformative approach which is helpful in building a cleaner, safer, and more sustainable for the future for the incoming generations. In fact, green chemistry play a crucial role in protecting our environment and achieving sustainability. Green chemistry is defined as the design of chemical products and processes that reduce or eliminate hazardous substances. Unlike in traditional chemistry, which focus mainly on product efficiency and cost, whereas green chemistry emphasizes on the prevention of waste, energy efficiency, and renewable sources. It more focus on less use of solvents, safer solvents, and biodegradable designing, which is helpful in removing environmental pollutants and provide a better future. Why green chemistry is necessary? Green chemistry is guided by the 12 principles, 12 principles which emphasize waste prevention, energy efficiency, and use of renewable resources. Green chemistry is necessary because in the rapid urbanization era, waste production is in more amount and creating air and water pollution. So climate change is going very fast due to the greenhouse gases emission and global warming. Therefore, this hazardous waste is increasing in the fast rate and causing contamination and health hazards. And these chemicals remain in environment for a longer time. So it is very difficult for us to remove pollution or these pollutants effectively because this process is very costly. So green chemistry provide an alternate that it prevent pollution at the source itself. So it is a preventive approach. Moving on to the application, of green chemistry in the present scenario. It in the pharmaceutical chemistry or in the pharmaceutical industry, it takes part in drug manufacturing, which are the life-saving medications uh, are produced and making the process safer and more sustainable. It provides a greener synthetic route, which minimize toxic waste. And during drug production in agriculture, where we use mostly agrochemicals, which are more harmful, more toxic, and causes health hazards. So most of the agrochemicals are replaced by biopesticides and biofertilizer, whereas in energy sector, green chemistry principles develop efficient battery technologies and cleaner fuels. In manufacturing, in manufacturing sector, generally biodegradable plastics, or we can say water-based paints and green solvents, replacing hazardous substance. So the importance of green chemistry in the sustainable development is that it it provides it provides a better future by conserving natural resources, reducing carbon footprints, and balances environmental protection, economic growth, and social well-being. These three are the pillars of the sustainability. So by reducing health risk and improving safety, green chemistry contributes to a better future, better quality of life. In conclusion, we can say that green chemistry is not an alternative approach, it is a preventive approach, it is a pathway for providing cleaner, safer, and sustainable future for the coming generations and ensure long-term environmental sustainability. Thank you.
Dr. Kanupriya Sharma very nicely presented the paper on the title Green Chemistry Eco-Friendly Approach for Sustainable Development. She is from Department of Chemistry, Biani Girls College, Jaipur. She has presented the paper with very clear, informative, and well organized overview of green chemistry as a vital tool for sustainable development. The paper effectively explains 12 principles of green chemistry. It also gives the relevance through diverse applications spanning across pharmaceutical, agriculture, textile, water treatment, polymer, nanotechnology, and industrial processes. Here, the inclusion of real world industrial examples like IKEA, DuPont, Dow Chemicals, Novozymes, TCI scanner, and practical case illustration. Now, this enhances the paper applicability and educational value, making it suitable for interdisciplinary audience at this international conference. I congratulate you, but there are certain point of improvement also which will improve your presentation, like there are minor grammatical and stylistic revision required for the manuscript which you have submitted for clarity and professional presentation. There are certain applications you can involve which span in last 3 to 5 years. Giving examples statistic would strengthen your contemporary relevance. Also, adding one summary table or schematic linking between chemistry and application would enhance readability. Now, these are certain minor improvement which will again improve your presentation and the manuscript which you have submitted. Again, I congratulate you. Thank you very much.
Good morning, everyone. I'm Sheeja from the Department of Environmental Science, University of Calicut, Kerala, India. My presentation today is on heavy metal contamination in groundwaters of Kerala, South India, seasonal dynamics, and risk assessment. This work addresses a foundational public health and environmental challenges critical to achieving the Sustainable Development Goals of Viksit Bharat 2047. Groundwater is a primary drinking water source in South India, as we all know, and its quality is severely and often silently compromised. The core environmental threat we investigated is heavy metal, and these elements are non-biodegradable and have a high biomagnification potential, posing severe health risk. In our study, we identify the top contaminants in order of severity. The first one is lead, iron, and cadmium, alongside others also posing a severe health like nickel and arsenic. These metals cause everything from chronic intoxication to serious carcinogenic effects. And the issue is not just if they are present, but how and when they mobilize in our complex tropical aquifers. To understand this dynamics, we adopted a robust methodology, that is, we conducted a seasonal sampling across pre-monsoon, monsoon, and post-monsoon periods across 33 well samples that includes unconfined and confined aquifers from Palakkad district of Kerala. And crucially, we employed a pollution indices, that is heavy metal pollution index HPI and metal index MI, to quantify the aggregate risk. And moving beyond a single element detections, we then used geographical information system and multivariate statistics to pinpoint the source and spatial distribution of these heavy metals. And our most critical finding is seasonal peaking of risk. And we found that the highest pollution with a mean HPA of 110 occurred dramatically during pre-monsoon season, where 66% of our sample exceeded the critical limit of this HPA 100. And why it is direct hydrological effects, the lowering of groundwater table, or we can say hydraulic head during the summer season, and which concentrate these dissolved ions in groundwater. Conversely, in post-monsoon season, the rainwater which dilutes these contaminants, and the extreme seasonal variability must fundamentally inform our monitoring policies. And the second, the most important finding is when we trace the source, let's show the highest overall contamination with the hotspot clearly linking spatially to highways and urban junctions. That shows a signature of automobile exhaust and urban runoff. And cadmium and nickel also peaked in urbanized zones, confirming their anthropogenic origins. And furthermore, acidic groundwater due to the acid rain enhanced the mobility of these toxic heavy metals, especially arsenic and nickel. And these heavy metals are also concentrating in the low-lying drainage channels. And this confirms that the hydraulic interactions between polluted runoff and shallow unconfined aquifer is dominant transport mechanism, highlighting the critical role of terrain geomorphology. In conclusion, our study provides the quantitative evidence that heavy metal contamination in Kerala groundwater is severe, seasonal, and originate from anthropogenic non-point sources. To transform this knowledge to action and guide Viksit Bharat sustainable future, we propose a three evidence-based policies imperative, that is a risk-driven monitoring, shift mandatory monitoring during pre-monsoon season where this contamination is very high, and integrate water management, implement source control measures that specifically target runoff from transportation and urban waste in hydraulically vulnerable zones. And prioritization utilize these HPMI maps for risk-based zoning to prioritize decentralized water treatment infrastructure where the public health risk is very high. And thank you for your attention, and I welcome technical questions regarding this work.
Thank you very much, Dr. K.M. Sheeja from University of Calicut, Kerala. Your title of the paper is Heavy Metal Contamination in Groundwater of Kerala, South India, Seasonal Dynamics and Risk Assessment. The presentation you have made as well as the manuscript which you have submitted, I have gone through both of them. They present a rigorous, data-rich, well-executed investigation of groundwater quality in Palakkad district, Kerala, with a specific focus on seasonal heavy metal dynamics and associated health risk. The study effectively integrates field sampling, laboratory analysis, multivariant statistic, pollution indices, and GIS-based spatial tools, providing a holistic assessment of groundwater contamination. If I speak about the best part of your paper and manuscript is you have given a season-wise comparative analysis. There are 3 seasons you have taken: pre-monsoon, monsoon and post-monsoon, which is clearly capturing the dilution and concentration effect. You have also given a robust application of HPI and MI indices, strengthening the pollution assessment and interpretability. Effective use of GIS tools also you have mentioned very nicely, which is appreciated. There is a strong public health relevance with clear identification of lead, cadmium, arsenic, nickel, iron and manganese exceedance against the BIS standard. Your paper has certain modification required for putting it to a higher value, like you should give a concise schematic summarizing workflow, like from sampling to analysis, indices to GIS. It will improve the clarity for readers. You can also mention or add a brief human health risk implications like HQ, HI or quantitative discussion, which will enhance the societal relevance. Here I would say that your paper, overall paper, makes a substantial scientific contribution to the groundwater pollution studies in tropical monsoon dominated region. Thank you very much.
Namaste. Myself Vishal Shah. I am a research scholar at the Sabarmati University, Ahmedabad. Today I will present a review article on From Import Dependency to Indigenous Innovation, a critical review of aluminium speciation and a roadmap for the affordable clinical diagnostic in a Viksit Bharat at 2047. As we stand on the threshold of a new era, looking towards Viksit Bharat at 2047, our vision is clear. A developed India requires a healthy, vital workforce. But today, I want to talk about the silent threat to this Swasth Bharat mission, that is aluminum toxicity. We often think of aluminum as a harmless cookware or a dust, but scientifically we know that when aluminum enters the bloodstream, its toxicity depends entirely on what it's bind to. When it enters the bloodstream, it binds with low molecular weight moiety like citrate and phosphate to form low molecular weight aluminum. It is not toxic, it is easily filtered through kidney and get extracted from the body. It also binds with transferrin to form high molecular weight aluminum. It is very toxic as it is not getting excreted from the body easily. Kidney is unable to filter it, so it get accumulated there and may cause renal failure. In routine clinical setup, pathologists just measure the total aluminum and not the transferrin bound aluminum. The real danger is not just a total aluminum, but it's a transferrin bound aluminum. Transferrin is a protein that transports iron to our brain and different part of the tissues. Aluminum is a molecular mimic. It hijacks the transport mechanism of the iron, creating a stable complex with transferrin that bypasses our body's defense and accumulate in the brain and other parts of the body. This is the root cause for neurotoxicity and renal failure. So why aren't we testing this routinely? The answer lies in our dependency on the historical methods. like ultrafiltration and speciation via HPLC ICP MS. Ultrafiltration method uses 30 kDa filters. When blood or plasma are added to the filter and then centrifuged, low molecular weight aluminum comes down in the filtrage and high molecular weight aluminum remains in the supernatant, and they are measured through the ICP-MS. But this method is very costly, and also some time due to acidic pH, the transparent aluminum complex got break and we may end up in having a wrong result, that is false result. HPLC ICP MS uses a anion exchange column. Acidic buffers are used as a mobile phase. Low molecular weight aluminum and high molecular weight aluminum are separated and measured via ICP MS. But this method has a very high runtime, around 20 to 25 minutes, and because of use of buffers, salt depositions are observed on sample cone, simmer, skimmer cone, torch, and injector of the ICP-MS. Nebulizer get blocks, that is, it damages the sample or introduction system of the ICP-MS. Historical standard method rely on instruments that are too slow, taking over 25 minutes per sample, and too sensitive to salt and leading to constant clogging and breakdown of ICP-MS. For a country with India's population and healthcare needs, relying on this expensive low throughput methods is simply not sustainable. To pave the path for Gurukul to global, we realized we could not just copy historical protocols. We have to innovate for our reality. In my research, we'll develop a novel high throughput speciation method directly using ICP-MS. We will engineer the chemistry that is rugged, which prevents salt clogging and protects the instrument. But most importantly, we need to slash the analysis time from 25 minutes to 3 minutes or lower. This isn't just an incremental improvement, it is a transformative leap that makes advanced diagnostic affordable for the common man. But we did not stop at speed. Historically, the developed nations have a passive follower of global guidelines. We decided to lead. While the international guidelines allows 30% error for the large molecules with challenges, our validator method will achieve a precision and accuracy threshold of 15%. We are proving that Indian science does not just meet global standards, it can redefine them. We are moving from a mindset of good enough to mindset of the absolute precision and accuracy. This research is more than just a chemistry. It is a roadmap for the national health security. By distinguishing the toxic transparent bond aluminum from the harmless fraction, we will empower our doctors to save kidneys and brains of their patient. This will be our contribution to the Atmanirbhar Bharat technology that is robust, rapid, and rooted in the priority of serving our people. Thank you.
Thank you very much, Shah Vishal Dilipkumar ji, a research scholar from Sabarmati University, Ahmedabad. You have presented your paper which is entitled From Import Dependency to Indigenous Innovation, a critical review of aluminium speciation and the roadmap for affordable clinical diagnostic in Viksit Bharat 2047. The paper which is presented by you as well as the manuscript which is submitted by you is highly insightful, scientifically rigorous as well as strategically aligned review addressing the aluminium toxicity through lenses of metal speciation, clinical diagnostics and indigenous innovation. By focusing on transferrin bound aluminium as a primary toxicological relevant species, the manuscript convincingly argues that the total aluminium estimation is insufficient for the meaningful clinical risk assessment. If I talk about your paper strength, you have a strong mechanistic depth explaining the aluminium's behavior, transparent hijacking, and Trojan horse mechanism across the blood-brain barrier. You have also given a clear differentiation between the free aluminum and low molecular weight complexes and transferring bound aluminum support by biological and toxicological kinetic reasoning. There is a critical evaluation of analytical techniques like SEC, HPLC, ICP, and MS with a practical insight into the contamination, salt deposition, runtime, and clinical feasibility. There is a compelling and original roadmap of Atmanirbhar, frugal, high throughput diagnostic directly aligned with Viksit Bharat 2047 as well as Swasth Bharat mission, national healthcare priorities. But there are also some suggestions from my end. If you give some mechanistic section which are highly detailed, can you shorten them a bit? Condensation would give or improve the readability of the conference, as well as if you include one or two schematic diagrams would enhance the clarity as well as engagement. Briefly, you can outline validation of parameters like LOD, LOQ, robustness for the purpose of SPE, ICP, MS approach would strengthen the its translational value. So adding a short subsection on targeting patient group like dialysis, elderly, occupational exposure would improve the clinical relevance also. I know the clinical trials are banned in India, but looking into the point, again binding with the legislation over here which is prevailing, you can also improve the research work, and you can also go further more and you can present even better. I again congratulate you. Thank you very much for your presentation.
Sashrika Ji from Punjab, and Namaste to all the Hindi listeners. I am Dr. Stephen Monday, a research fellow of the Faculty of Allied Healthcare Sciences, Desh Bhagat University, presenting on behalf of other 4 authors this paper, which is entitled Water Quality Assessment and Burden of Waterborne Diseases in Girl and Due Communities of Jos South Local Government Area of Plateau State. Other authors are Mrs. Shuachet Daniel Gimbason, research assistant from the Community Health Department of the Wesleyan University, Professor Dr. Daniel Gimbason, the HOD, and Professor Dr. Daniel Marafi Gimbason, the Dean and Head of Department Community Health, Wesleyan University and Nasarawa State University. We have Amina Elisha Anipan. She is equally a research assistant at the Community Health Department of the Wesleyan University, Ondo. And lastly, we have Ravi S. Gibson. She is a nurse and a research assistant at the Echo Health, Liberia. So I give you the background of our study. Our study, safe water is very, very important for health. And as you all know, many people still rely on the sources of their drinking water in Due and Girl community from open water sources and open wells without treating the waters. So this has caused them to incurring a lot of diseases, waterborne illnesses, such as diarrhea, typhoid fever, and which equally indicates poor sanitation in those areas. So the study was conducted to assess the sources of their drinking water, how they handle their drinking water, and how waterborne diseases affects the people of Girl and Due communities. So our methodology involves recruiting about 807 participants from Girl and Due communities. And these participants responded to a set of structured questionnaire which highlighted the household drinking water sources, storage methods of the households of those communities, their hygiene behavior, and how they relate with their various community and how they contracted various diseases in the last 6 months. Water samples were then collected, and these water samples that were collected were from sources as wells, open water, streams, rivers, and other household water storage sources. The water samples were analyzed for simple quality indicators of pH, turbidity, and bacterial contamination. These bacterial contaminations were assessed for E. coli bacteria and coliform bacteria. So from these methodologies, we have come out with deduced results like the results indicated high reliance of household on drinking water sources were unsafe, with the majority of those who consume water from the wells without protection and surface waters coming down with sicknesses like typhoid fever and cholera. Laboratory analysis indicated many samples contained unsafe levels of bacteria such as coliforms and E. coli bacteria. Is an indicative of fecal matter present in the source of their drinking water. A large number of respondents reported to have come down with diarrhea and typhoid fever in the last 6 months, as have been said earlier. These points a strong association between water quality and public health concerns. Conclusively, we can see that drinking water in Girl and Due communities of Jos South local government is not always safe, leading to high burden on waterborne diseases, which has to do with consumption of unclean drinking water. So improvements in water supply systems are urgently needed. We need to improve the sources of drinking water in Girl and Due communities, and we need to give a lot of household promotion on water sanitation and hygiene. Treatment and improved water sanitation and hygiene practices is needed in order to safeguard public health. Thank you.
Thank you very much, Dr. Stephen Monday, Research Fellow from Faculty of Allied Healthcare Sciences, Desh Bhagat University, Punjab. You have given a nice presentation on water quality assessment and burden of waterborne diseases in Gale and Due communities of Jos South LGA. Your manuscript which you have submitted as well as the presentation was well structured, and it was community focused, policy relevant study assessing the drinking water quality and the burden of waterborne diseases in a typical selected region, locality. Now it was definitely a good one by combining household survey with a basic physicochemical and microbiological water quality analysis. The study effectively establishes a clear link between unsafe water sources, poor handling practices, and high prevalence of waterborne illness such as diarrhea and typhoid. Now, the strength of your paper which you have submitted is, one of them is you have taken a large sample size, 800 plus, which enhances reliability and community level findings. You have also integrated laboratory tested water quality parameters like pH, turbidity, total coliforms, E. coli with self-reported health outcomes. You have also given a clear identification of high risk water sources. You have also very strong public health relevance which is aligning to SDG 6, which is clean water and sanitation, and this is also very relevant to Viksit Bharat vision for preventive healthcare and sustainable development. Here there are certain improvements also needed, like inclusion of basic inferential statistic like chi-square test would strengthen the association between water quality and disease outcome. You can also give a brief clarification of laboratory protocols and quality control measures would be enhance the methodological transparency. Along with this, mentioning the season of sampling and its influence on contamination level would improve the contextual interpretation. Adding also a simple graph or map showing water sources and contamination hotspot would enhance your readability, as well as a short alignment with national or regional water policies would strengthen governance relevance also. So I congratulate you for presenting very nicely. Thank you very much.
Hello everyone, my name is Suhasini Jindal. I'm a PhD scholar at Amity Institute of Environmental Sciences, and I'm also working at EXL Service in the Environment Sustainability team. So I'm very glad and very thankful for giving me an opportunity to present at the 4th International Virtual Multidisciplinary Conference. So the topic for my presentation is building climate-ready institutions, the role of higher education in advancing Scope 3 emissions literacy and sustainable corporate practices in Viksit Bharat 2047. So this presentation will include a background of what decarbonization is, what Scope 3 emissions is, then a perspective of the IT and ITES sector, measurement challenges of Scope 3, the educational imperative and Scope 3 literacy framework, global and Indian best practices, higher education institutes and corporate collaboration models, and policy alignment and Viksit Bharat 2047 glimpses, and some recommendations followed by a conclusion. Just to give a brief background about what the need is. So corporates play a big role when it comes to net zero emissions. And since India has a net zero goal of 2070, it becomes very important for corporates to set up some targets and reduce emissions. Now, when it comes to IT and ITS sector, since I belong to that sector, so I can specifically talk about it. 70 to 90% of the emissions are due to the Scope 3, which basically Scope 3 is basically the indirect emissions which are not really in the companies or organizations' control. It is basically the supply chain and all the raw material or everything which comes under supply chain becomes Scope 3 emissions. And Scope 3 is something which is very difficult to measure and understand. Now, the real gap is not technology, but talent and literacy, because calculation of Scope 3 is difficult. It needs immense knowledge and immense calculation techniques to understand and present something valuable. Now, higher education systems, they are the bridge. They are capable of shaping climate-ready leaders who can, embed Scope 3 thinking into corporate strategy, culture, and national sustainability outcomes. To give a background about what Scope 3 emissions generally is. So Scope 3 emissions, as I said before, they are all indirect emissions, which, across the value chain, both upstream and downstream. So it is basically divided into 15 categories under the GHG protocol. It covers the business travel, purchased goods, capital goods, employee commuting, waste, investments, leased assets, etc. Now, for most of the ITS companies, or you can say service sector companies, Scope 3 accounts for almost 70 to 90% of the total emission portfolio. We have three categories in the emission portfolio, which is Scope 1, Scope 2, and Scope 3. So Scope 1 and Scope 2 is the direct emissions, which is directly under our control. But Scope 3 is something which is not in our direct control. Therefore, they are also known as indirect emissions. Now, for the service sector industry, since they are not very energy intensive, so Scope 3 is the primary category which is emission intensive, and it forms around 70 to 95% of the total emission portfolio. Now, scope 3 is something very complex to measure because it depends on external data. It depends on external factors like the suppliers, their transparency, calculation methodology, and global multi-tier supply chains. Now, why is it difficult to measure scope 3? The question here. So, first reason is the lack of data and lack of quality in that data. So, most suppliers in India, they do not report their emissions because net zero in India is not something you will hear every other day. So suppliers, they do not disclose their data. Therefore, the companies rely on the generic data or the outdated emission factors. The second point is the dependence on spend-based methods. So there are basically two methods where you can calculate the scope 3 emissions. One is the activity-based method and the other one is spend-based method. So activity-based data is basically what you do, you record that data, you have the records, you have, for example, if you are consuming water, you have the data as to how many liters or kiloliters have you consumed. So that comes your activity data. But spend-based data is basically if you've consumed around 1 kiloliter of water, then what is the cost of that 1 kiloliter? And then you calculate emissions associated with that spend. So spend-based data is not very accurate when it comes to emissions. So the most accurate and the most widely accepted methodology for calculation is activity-based data. So that is mostly lacking with the firms. So firms usually they use their spend-based data, which causes large inaccuracies and it does not reflect supplier-specific realities. The third reason is the fragmented internal systems. So all the teams who are involved in a company's build, they, for example, procurement or travel or finance or operations or technology, they work in silos. They have the data also in segregated, a little scattered, which makes it difficult to consolidate and standardize and validate that scope 3 information. Now, the fourth point is around the methodological uncertainty. So every category requires a different methodology and every category require different calculation approaches. And there are no specific guidelines or no one or, a global certified guidance which can guide onto how to do the calculation. So it creates a confusion, which is right, which is wrong, which one should you adopt and which one should you leave. Coming to how higher education systems can help here. So higher education systems should integrate scope 3 education to create a workforce capable of managing value chain emissions. So generally, when we pursue subjects like environment science or environment management, subjects like scope 3, calculation, methodologies, technology, these are the subjects which aren't included in the education. And this is where it creates a gap wherein whenever the students they get into the corporates and they get into environment sustainability teams, they have no clue about what is scope 1 and 2 and 3, how to go about it, how to understand it. So they do not know the basics of it. So it is very difficult for anybody to expect anything else other than that. So students should acquire scope 3 literacy, including category understanding and the GHG protocol methods. Then again, practical skills are essential from data interpretation to designing scope 3 reduction or decarbonization strategies. Here are some of the global and Indian best practices. So one is from the leading global universities like Toronto, Melbourne, UNSW. They embed scope 3 accounting into coursework using real institutional data. Then business schools under PRME, they integrate sustainability and emissions literacy into core management curriculum worldwide. Copenhagen Business School and similar institutions, they offer carbon literacy certifications linked to practical corporate applications. Then when it comes to India, so Indian institutions like Shiv Nadar University and some of the IITs and IIMs, they conduct full scope 3 assessments and use them for student-led analysis projects. Industry academia models in India like Infosys or TCS, they showcase how partnerships can strengthen sustainability, teaching, and research. Now, how the education institutions and corporate systems, they can collaborate. Now, here are some of the strategies by which collaborations can happen, and it can benefit both the higher education institutions and the corporate companies. So first is the joint research projects. Universities and companies, they can co-develop scope 3 measurement methods or models or strategies and for decarbonizing scope 3. Student consulting in life projects, which is that corporates provide real data sets and sustainability challenges for students to analyze and solve. Then practitioner-led teaching, wherein industry experts deliver guest lectures or they co-teach modules or serve as adjunct faculty in ESG and carbon accounting. So basically the major crux here is to introduce carbon accounting and scope 3 or ESG as a full-fledged subject in environmental sciences and environment management. Then again, internships and talent pipelines where structured sustainability internships can create a steady flow of scope 3 literate graduates into corporate roles. And as I said before, that basic things like ESG and corporate sustainability are not taught in higher education institutions. So it's important for them to understand and include this in their curriculum so that if the student goes into a corporate, if they get absorbed in a specific company in the environment sustainability team, they don't have to start from literally basics. Then executive education and upskillings, the institutes can offer short-term programs and certifications to train corporate teams in scope 3 accounting and value chain sustainability. Now, India has a Viksit Bharat 2047 plan, and to emerge as a sustainable and eco-friendly nation. And to reach this future, there must be policies who speak the same language, whether it is climate action, digital growth, everything cohesed into one single thing and moving on. Then education, industry, and government should come together and in order to align skills, in order to drive innovations and form such regulations for 2047 vision as well as the 2070 net zero target. Here are some of the recommendations, which is to establish national task force on climate literacy in higher education. Then facilitate industry academic research partnerships where both the industry experts and the academic research experts, they come together, they collaborate, and they introduce programs and they introduce skills so that the students can learn and follow up. Then establish sustainability faculty development program, formalize corporate partnerships, engage in project-based learning wherein the corporate can give projects to the education institutes and the students, and they can analyze and give them solutions. Facilitate internships and employment and support professional certification. Just to conclude, as I said, India has an ambitious 2070 net zero target, and it has a Viksit Bharat 2047 future of an aim. And to reach both, there has to be a proper roadmap wherein the higher education institutes and the corporates who form a major sector in our economy as well as in our education pool, they should come together, they should think of solutions. Scope 3 or ESG for that matter should be a part of the curriculum of students, and it should not be just for people or the students who are getting into sustainability domain, but it should be something which should be embedded into the curriculum of all fields, Sustainability is something which has to be a part of every field. Everything, when gets sustainable, will lead to a sustainable India. So, with this, I end my presentation. Thank you so much.
Thank you very much, Suhasini Jindal from Amity Institute of Environmental Sciences, Amity University, Noida, Uttar Pradesh. You have given a presentation on building climate ready institution, the role of higher education in advancing scope 3 emissions, literacy and sustainable corporate practices in Viksit Bharat 2047. You have given a thoughtful presentation and which was policy relevant and well articulated review article highlighting the strategic role of higher education in advancing scope 3 emissions literacy and shaping the climate resilient corporate practices in India. It was successfully positioned HEI not only as a knowledge disseminator but also as an active change agent capable of influencing the value change decarbonization through its curriculum design, institutional practices, and industry collaboration. In your presentation as well as the manuscript which you have submitted, there is a clear alignment between Viksit Bharat 2047 and India Net Zero 2070 commitments. There is a strong conceptual linkage between the academic climate literacy and real world corporate sustainability action. You have also integrated policy framework, institutional perspective and sustainability education theory. Now this is commendable, as well as there are certain improvement or constructive suggestions from my end. If you can include one or two brief Indian HEI or corporate linked examples would strengthen the practical grounding of your paperwork or presentation. There is a simple conceptual model linking HEI, scope 3 literacy and corporate outcome would enhance clarity. Here I am also very happy to share that mentioning the indicators and matrices would also add value to your paper. So conclusively, you have given a very nice review paper. Thank you very much.